simplifying fractions. Let's move this over here. Can you see over? Oh, there's hardly anyone there. Rational expressions. Okay, so do you remember this from last year where we had to factor first? Yeah. And then, right, we cancel out. We reduce out. Yay, review. Okay, you did it this morning. Yeah, okay, so that's review. So when we multiply, where you multiply tops with tops and bottoms with the bottoms, right, straight across with fractions. And when we divide, we have to flip and multiply by the reciprocal. We multiply by the reciprocal. Flip and switch, right? The switching the sign. Flip and switch. I just always thought that reminded me of like Legally Blonde. And flip and switch. I don't know. Like MPVs, you might. Non-purpose, but we should technically look at those. In your homework, we don't know necessarily because we're just simplifying and not solving. Okay, so we're just going to simplify today, and I'm not going to stress about MPVs. So let's review. Let's go look at this guy. So x squared minus 16. Can we factor him? Kate. You got it? Okay. Difference of squares. What does it factor to? X minus 4, x plus 4. What about the bottom? We factor out the x cubed. Times. I like times symbols instead of x's because then they look like x's. Right? You know what I'm talking about? Okay, it's not gibberish. Okay, what can we factor out of the numerator? X squared. You guys are good with your factoring. Yay. X plus 2. And then what can we do with the bottom? X plus 2, x minus 2. We got skills. Can we go straight to simplifying here? Or do you combine and then simplify? We can just simplify. What can reduce out? X plus 4s. And the x plus 2? X squared and x cubed. What can we get? Just a x on the bottom. Okay, so our final answer is on the numerator we just have x minus 4 all over x times. Oh, could we just put them together right off the bat? Can I? I don't want to write things twice. Okay, let's do no restrictions. So when do we do our restrictions? Before and after. Yeah, basically look at the factored form before cancellation. Right, so starting here we have 0, negative 4, plus or minus 2. Very good. Those are our restrictions. Yay! So that's okay, right? That's review. Adding and subtracting. Everyone loves adding and subtracting fractions, right? No. Why is it more work to add and subtract? Yeah. Unless the denominators are the same, we can't add or subtract the numerators. So we have to get a common denominator. How are we going to do that? Well, first step is still factor. Okay, I have some examples here. Let's skip that one. Okay. Okay, so can you factor this guy? Since you're so good at factoring? No? Yes, you can. Yes, you can. Okay, you should all get that far at least, right? Multiplies to negative 3, adds to negative 2, negative 3 and positive 1. Okay, now, do we have a common denominator? Can we make one? Greg, is everything okay? Yeah. Okay, so what's missing from, what do we need here? X plus 1. We'll add some brackets here, top and bottom. And what's missing on this side? An x. So x times x. That's a really ugly x. That's better. Okay, so when you were writing this out, did you normally go straight to writing it all over one denominator? Just like this? All over x times x plus 1 times x minus 3. These are always so much writing. Now what? Distributive law? Okay, so let's expand this. Could we do this without, we can do this, right? X times x squared plus x times 5, 5x. We don't have to draw the arrows anymore, right? Or do we? It's okay if you do. No judgment here. 1 times x plus x, and 1 times 5 minus 5. What are we going to bring in here? Oh, thank you. Somebody's paying attention. Negative x, right? We're going to bring in the negative with it. Negative x times x, negative x squared, and plus 2x all over. I'm going to run out of room. Okay, now what? The x squareds will cancel. Then we have a 6x and another 2. 8x minus or plus 5. All over, and then restrictions we should always do. Don't be lazy. Hey, x can't be 0, negative 1, or 3. Okay, so this stuff should be good review, like total review. You know how to do this, right? Or you just need some practice maybe. Do we need to do this next one? How much is left today? Should we do one more or should we move on? Okay, well that's easy. I didn't leave enough room for this one, but that's a really cool question. What's wrong with that? Yeah, deal with them separately. So like this guy, in order to add these, like this is like one thing, you need a common denominator. So you would make that x minus 1 on top and x minus 1 on the bottom. So you have to deal with them almost separately. We don't have to go through this, right? But it only looks bad. It's really not that bad. Right, now we have a common denominator, so you can combine those. Again, same idea, so top and bottom of x minus 4, you're going to multiply by x minus 1. Yeah, and then you can simplify the numerators and then divide, so multiply by the reciprocal. So it's a lot of writing. If you want to work it out, I have the solution here. I end up having to find another piece of paper to work on, because there's obviously no room here. Okay, but a cool question. Would I give that to you on your test? Probably not, because on a question like that, you're guaranteed to make a stupid mistake, right? You just know it's going to happen. Okay, so let's talk about radicals. What's the square root of a squared? A. If we have root c plus b root c, a root c plus b root c, what can we do if we have the same radicals with different coefficients? Add the coefficients. So this would be a plus b root c. What if we're multiplying radicals? If I have a mixed radical, 2 root 3 times 6 root 5, what can we do? How do we solve those? Yes, so a times c root bd. Very good. Radicals with radicals, coefficients with coefficients. Same idea here, right? Coefficients A over C, root B over D. It's kind of hard to explain that one with letters, but we actually, yeah, that was great. That was last year. You got to add and subtract and multiply radicals, right? Okay, so let's try something for fun. Here, what's the product going to be? 35, so 5 and the 7, so 35 root 18 plus, we simplify that. Root 2, 42 divided by 21 is 2. How do we simplify radicals? How can we break down 18? Take the 9 out. Yeah, we can write this as root 9 times root 2. And square root of 9 is 3. I like to cross it out, write a 3 here. What do we do with these two numbers? Multiply them. 35 times 3, 105. Root 2 plus root 2, which actually gives us 106 root 2. That's fun. A binomial with a square. What do we do when we see a binomial with a square? You run and hide. No. You get excited. Foil. Thank you. Write it out twice. We're going to foil this baby. Don't run and hide. Okay, I love these. It feels like there's like for every one, there's like 2 multiplications going on, right? Because we are doing 4 root 3 times 4 root 3. So 4 times 4, 16 times, what's root 3 times root 3? 3. So it just becomes 16 times 3. Or you can write root 9 if you really want to. Okay. 4 root 3 times negative 5 root 6. Negative 20 root 18. And then again, it's a perfect square, so it's going to have the same middle. You don't even have to think about it. I mean, you could check your work. Negative 20 root 18. Yep. And then root 5 root 6, negative 5 root 6 times negative 5 root 6 plus 25 times 6. Okay, what's 16 times 3? 48. Before we simplify, can we combine these guys? Minus 40 root 18. 6 quarters, I have $1.50. 6 cookies, exactly. Okay, oh, I'm sorry, I'm rude. This is Mr. Bohr. Forgive me. He's hanging out with us for like a while. Okay? What do they do? They're student teachers. Yeah. Mr. Bohr. His name's over there. Yeah. Just a little. And fun fact, he has a cousin in school. I won't say who. That's just a cool fact. No, it's his secret to tell. Okay. Maybe he doesn't want to know. Maybe your cousin doesn't want people to know. Who knows? Probably not. Okay, moving on. Okay, now you guys have a challenge. Okay, 48 plus 150. 198. Minus, can we simplify this? Can we do this all in one step, folks? It's 9 times 2. What's the square root of 9? 3 times 40? 120 root 2. We are ballin'. That's not funny. Okay, that was fun. So, you know what's new today? There is going to be something new. I know it's so boring. I've seen this stuff before. Don't worry. There is something a little bit new. Not a lot new, just a little bit. Okay, so conjugates, we talked about that a little bit already, right? We want to make a difference of squares so that the radicals are gone, so we can get rid of the radical on the denominator. Here's a news flash. Sometimes we want to actually rationalize the numerator. That's the new part for today. You'll see more when we get to limits and derivatives. Okay, so there will be a time where you may have to rationalize the numerator, not just the denominator. Okay, so that's what's new. So let's rationalize the denominator here. What are we going to multiply top and bottom by? Root 5 plus root 2. We want to make a conjugate pair so we have a difference of squares. Because a difference of squares, if you have a minus b times a plus b, it's always equal to a squared minus b squared. Right? There is no middle term. And if we square a square root, guess what? It's gone. Okay, so let's do some math. Root 6 times root 5. Root 30 plus root 12 all over. Root 5 times root 5. Root 25 or 5. Negative root 2 times positive root 2. Negative 2. Okay, 30, we can break that down, can't we? Or can we? Ooh, no, 9, no. No. Well, our numbers are, does 4 go into it? Does 9, 16, 25? Okay. So, yeah, 12. Yeah. 4 times 3, so it becomes 2 root 3 all over. Thank you. Thank you. See, I once, a long time ago, with my calculus class, said if I made X amount of mistakes, then I'd bake a cake for everybody. And I had to bake cake, so I'm not doing that anymore. I know, cake's so good. There we go. I could buy cake. That's true. No. I'd be a lot more careful if I had to be careful. But I know that part of your learning is you catching the mistake. I don't want to take that away from you.
You get a lot of mistakes over the year. You buy a cake as saying sorry.
Okay.
If you don't, you get a cake to say yay.
Actually, one. Okay, we'll see. We'll see. The more people that drop, the easier it is to do this. Not that I'm encouraging anyone else to leave. Okay. No, I don't. We just didn't have enough textbooks. Now we do. Okay? No offense to everyone. I don't know, there's some people who they never showed up on the first day. Their eyes are bigger than their stomach. But it's hard to balance everything, right? Okay, what's the conjugate pair here? Okay, what's the conjugate pair here?
X squared minus 4 plus minus.
X squared minus 4, so the square root of that, and then instead minus x. Nice. Okay. Well, just wait. Let's just write the conjugate pair. Let's expand this now, okay? So 12 root x, we can even leave it in factored form. Let's leave it in factored form. Root x squared minus 4 minus x. On the denominator, what's square root of x squared minus 4 times square root of x squared minus 4? Yep. I'm just going to leave it in factored form. It's fine. You can. Just in case something cancels out later on. And then we can expand the numerator later. Okay, x squared minus 4, the radical's gone. And then negative x times a positive x. Negative x squared. Do you see why, Jamie, now You'll see in a second. To leave it factored just in case something cancels out, then we can expand it in. So here, what happens? X squared minus x squared is gone. We're just left with a -4. Can -4 go into 12? Yeah, how many times? -3 times. Minus x. So messy, sorry. Do you see why if we leave it in factored form, something might cancel out? That's why it's good to leave your numerator in factored form. Okay, do you want to try the next one on your own? You can, it doesn't matter, it's fine. Usually with simplification, yeah, you do. Try this next one on your own. Did I do my math right? 45 minus 1. And yeah. Yeah, okay. And then we can reduce these. We can divide both by 2. 6, oh, 3, no. 4. 12, no. No. So divide both by 4 over 11. And you can bring in the 3 if you like. Yay. So that's why I'm going to keep it factored in the numerator just in case something cancels. So what's new? Being able to rationalize the numerator. And this is going to be a formula, something to a formula, example 5, just that will, okay, give me a second, I could speak. That is going to be similar to a substitution you'll make for a formula in limits. So you will have to rationalize the numerator at some point. And so that's the new skill for today. How is it different? It's not different. The only difference is now we want the radical on the denominator. We don't want a radical on the numerator. So we still use our conjugate pair. What would it be in this case? Root 2x squared minus 3x plus, instead of the minus, x. And things like this are so ugly, like it's better to leave it in factored form anyways on the denominator. Plus something might cancel, and often it does in the future. Okay, did you write that down? Should I give you a second? Let's do some difference of squares here. Square root of 2x squared minus 3x times square root of 2x squared minus 3x is 2x squared minus 3x, and then negative x times positive x, negative x squared. Leave the bottom in factored form. Trust me, you're better off that way. Look how ugly this thing is. You think this is ugly? Wait till we get to the next one. Okay, what can we do on the numerator here? This is a 2, forgive me. So, yeah, click x squared minus 3x. We can take out the x. Are we? Okay, here's the thing, folks. I don't want to write this all out twice because it's a lot of writing. So this is going to simplify. Would we agree to x squared minus 3x, right? Would you agree that that's what's going to happen on top? So what can we factor out of that? An x. Ooh, this is amazing. What just happened? Yeah, x minus 3, gone. And nope. Oh, well, see, let me talk to you about that. No. Let's talk about that. Okay. Why can't we do this, right? We can only simplify monomials with monomials. It has to be in factored form. And binomials with identical binomials, if that makes sense. Like x plus 3 divided by x plus 3. This plus, or this plus here, is attached to this guy. They belong together. Okay, they belong together. You trying to separate their love? Or I don't know. Okay, okay, this is what I explained. This is what I explained to block 3 actually. We went through the same concept. And we talked about, let's make this something else. Let's make it like a, no. But we were talking about this exact same concept. Why can't we cancel out the 2 x's? Because these are attached, they are one thing. You're ripping limbs off of a body. That's basically what you're trying to do. That's the morbid side of it. Okay? You can't, there's invisi brackets here. If you have to, you can draw them. But these belong together. You can't simplify. Only if binomial identical to binomial divided by identical binomial. Clear? As mud? Okay. So the x's, because he is a plus sign here, he's not factored out. He should be factored out if he's going to cancel. Okay. We're happy? I don't know. 2x squared minus 3x, such an ugly thing, plus x. There's our final answer. So I think, is he our last guy for the day? He is. So let's rationalize this numerator. I love this guy. Yeah, awesome. It's mean. No, it's not mean. It's just a lot to write. You just gotta be very neat. It really helps if you're neat. And some of you, if you're not neat, then you misread your own stuff. Okay? So, what's the conjugate pair for this beauty?
2x plus 2h, square root 2x plus 2h minus 1 plus
Plus square root of 2x minus 1. Good. So you just got to write that all out. No, you cannot use right ditto. That is not mathematically valid. Okay. No, don't even argue. Don't go there. Okay. Conjugate, so difference of squares, right? We can a squared minus b squared is equal to a minus b times a plus b. So just these multiplied together, right? Just square it, and just those multiplied together. So what happens when you square a square root? Goes away. So we have a 2x plus 2h minus 1. And then we have a negative root 2x times a positive root 2x, negative root 2x minus 1 times a positive root 2x minus 1. Negative. Careful. We need the brackets. So it's minus the 2x minus 1. You okay? Yeah. Okay. Because I think I did a very bad job of explaining that. So let me know. You need me to go through that again. And then h times root 2x plus 2h plus 1. It's a minus 1, thank you. Okay. You can put the first bit in brackets. It really doesn't matter, right? Because there's nothing affecting that in the front. So it doesn't have to. But you might like it, because then, yeah, I don't know. Okay, when we subtract, how do we subtract polynomials? So just subtract. Okay, so then 2x minus 2x, no x. 2h minus, there's no h, so we're still going to have a 2h. What about negative 1 minus negative 1? 0. This is why some of you might want to change this to plus and switch your signs. Remember when we did that in grade 10? So then, no. 2 plus negative 2 is 0. Negative 1 plus 1 is 0, right? All over, guess what happens? The h's cancel out. This is a very significant thing that we're going to learn about soon. Oh, very soon. These h's cancel out, right? This is factored out. But no, because it's not an h squared. Just a 2. Yeah. So then we have 2 divided by root 2x plus 2h minus 1 plus root 2x minus 1. That is ugly. Yeah. The h's canceled. That's pretty cool. Okay, so that's it for today. How are you feeling? Does your brain hurt yet? A little bit? Okay, homework. It's on the website, but I can tell you if you're ready to circle. Get ready. Get it out. You can also write it on the board, you know. There are other options. Okay, lesson 3. Ooh, this is going to be super easy to circle. 1, yep. A, D, G, J, M, O. 2, A, C. These are the minimum. You can do more if you'd like. Okay? 3, B, E. 4, that is not acceptable. 3, B, and E. 4, A, and C. Some of these are really quick, like half plus 2/3. Okay, and then 5F, 6B. 5F, 6B. Okay? So we have about a half an hour today for homework, which is beautiful. I'm sure you could use that time.